Welcome to our international conference of Sustainable Engineering and Digital Innovation podcast series. In this podcast, we'll go deeply in AI, super AI, creation, and learning. Today, we have a special guest, one of our keynote speakers, who delivered a really brilliant talk today morning. We have our guest. Welcome to Professor Simon See, Senior Director and Chief Solution Architect in NVIDIA Corporation in Singapore. Welcome to our podcast.
Thank you very much for having me here.
And thank you so much for your keynote speaker today morning, which was brilliant, covering AI and everything.
Oh, it's my pleasure. Thank you.
So, as you already started the conferences and you already delivered your keynote speakers, starting communicating with the people, so how was your experience so far?
Oh, my experience so far is absolutely great. I learned that there is a lot of people in Oman, young students, young people who are so enthusiastic about using latest technologies such as artificial intelligence and so forth. And I think it is a great time for Oman to invest more into artificial intelligence, getting more of the people to work on this such a technology. And the future is all bright.
Yeah, that's true, and it's really also interesting that these young generations will be in contact with such personality like you. So before we dive in, let's go and take our audience into little bit milestones into the Professor Simon See career.
Right, sure. So interestingly, I'm a trained applied mathematician. And over the period of my career, I was working on computational science, for example, like computational fluid dynamics, electromagnetics, and so forth. And then I accidentally steps into artificial intelligence along the way. Long before artificial intelligence became artificial intelligence, we were looking at ways of finding algorithms that's able to fit data that were collected, right? And so we started working along the line. And then sometimes in the early 2000s, the algorithms become more mature. And also at the same time, there is more the computational aspect of it. There is more computational machine become more powerful and so forth. Then of course, over the last few years, artificial intelligence become a mainstream, so forth. And a lot of us who are in the doing computational science, I'm still doing science, by the way, that we take the science problem and try to use artificial intelligence to solve it. And that's where how I get into artificial intelligence is through that. And in this course of work, I learned a lot of things about artificial intelligence.
That's great. Professor, now, during your speech, you mentioned something mathematical, then you spoke about algorithms, then you spoke about computational, and how it's related to all science. This generation, they thought that AI is just programming, where actually should not be only programming. So can you elaborate more about this?
Oh yes, definitely. It is. Artificial intelligence is something that we actually have not really understood it very well, right? And there is a couple of aspects of it. One of them is we must look from the artificial intelligence from the intelligence domain itself. The other part is that we must look at how artificial intelligence can be applied into particular domains, right? And the basic of the artificial intelligence is applied mathematics. The mathematics that is allow us to do many of these things. Linear algebra, numerical analysis is a fundamental basics of the foundation of artificial intelligence. So mathematics is very important. Now, on top of it, when we go into more advanced artificial intelligence, there is something where we need to actually have advanced applied mathematics to apply to it to understand the fundamental functions of the algorithms. At the moment right now, we do not still understand it. So that is why mathematics is extremely important. Now, going on to the other side of it, where you apply AIs into the domains. Domains like physics, domains like biological science, domains like medicine or whatsoever. Now, without the domain's knowledge, applying AIs into these things is very, very extremely challenging because you do not understand the domains. So you need to have a combination of the artificial intelligence knowledge and domains, right? Programming is not the basic of it because artificial intelligence is going to slowly replace, I wouldn't say totally replace, but partially replace algorithms, writing algorithms. You must think of the basic science, the basic mathematics, and the domain in order to ask the AI to develop the algorithms for you to solve the problems.
Exactly. From here, we can jump into the point also. You mentioned something or a term called it super AI. Now, what is the real difference between normal AI that we know today and super AI, which is expected and predicted to be in the future?
Right. So the thing is that at the moment right now, so there is a three class of things. One of them is that at the moment right now, most of the algorithm design are extremely narrow. They can do only one thing extremely good, right? And then the community is trying to build something what we call AGI, Artificial General Intelligence. Basically, it's general intelligence. Basically, it means that you're given any task, you're able to solve any task generally. Now, the super intelligence, it means that basically you are able to generalize and yet do every single thing that is given to it at above human capability, at a superhuman capability. That's why we call it ASI.
Oh, that's interesting. Now we have AI, which is becoming faster than human reasoning, creativity, and also strategic judgment. But through that all, how we can maintain the accountability and responsibilities when it's coming to running all of these AI systems?
Yes, that is a very, very important question. AI is something that we actually build. We can make it do good. We can also make it do bad things, right? So it is very, very important that we are able to actually control it, have some governance of it, and how it can be used. The other things is that especially when we come to ASI or AGI, those are the times where the machine become autonomous. And when they become autonomous, we need to have a way of telling the autonomous things that under certain human value, it can do and it cannot do certain things. And that is very, very important.
Yes, exactly. And managing also the machines in terms of what data set is giving to these machines and functioning based on that. Professor, also you mentioned during your speech kind of what we called it AI agent and how it's functioning. Now we can see SMEs, small and medium organization businesses, they are running in a marathons of adopting AI agents. Unfortunately, somehow, in some points, this AI agent fails into functioning because of the poor functionality or improper functionality. So what are the standard functionality in AI agent where we can say that this is a really good AI agent?
Right, good. That's a very good question. Now, one of the very important thing is to define what you want to achieve. Once you define what you want to achieve, then you create certain benchmarks, right? I mean, for example, if you want your artificial intelligence to able to go through all these Arabic documents and then produce a certain insight into it, then you need to create a benchmark that's able to measure how accurate this agent is able to read all these documents accurately. And if your benchmark is 98% is good enough, then that's a benchmark. So you can try different type of agents or different type of methodology to say that if you cannot achieve 98%, that is not good enough. It's not going to be used.
Exactly. So the testing is most important part. Rather than jumping in and adopting immediately, you need to try different agents and see how they are functioning over their system, rather than putting your business in risk by adopting this AI agent. There is one term also I detected in your speech today, which is alpha coding. So I think this is alpha coding is a term that our programmers need to take care of. Can you speak about this?
Well, Well, at the moment right now, you could see that the community is building a lot of technology that's able to help us in coding, right? Now, coding is, like, as I mentioned earlier, is going to be lesser and lesser, all right? Software engineers is now going to be producing products, not just coding. They are going to be system level thinking. They're going to be doing critical thinking. They're going to be data governance and so forth. So coding become a sub-task because now AI agent is able to do the coding for you.
Yeah, that's true. Dive into the challenges. AI world is not that perfect, but also we have challenges. One of them is the cybersecurity challenges and auditing challenges.
Yes.
So the term of AI audit, how is important these days?
Yes, absolutely. That is in fact one of the very important things that the community need to address, and the governments actually need to address it. Cybersecurity, AI agent is not going to be autonomous, and it's going to do things that sometimes we don't even know that it is doing it because it's autonomous, right? So security cannot be an afterthought. It has to be built in. It has to be designed right in the beginning, right? And not after you design the algorithms. You have to design right in the beginning that such a security risk or things is going to be there, and how are you going to mitigate it before you design the algorithms.
Exactly. So consider as one of the main steps of any AI project has been run. Last question from my side. One advice to pass it to student researchers, academia, and industry who are working in AI today.
Well, AI is going to move very, very fast, exponentially, right? So my view is that we need to be adaptive, learn things extremely quickly, and so forth, and then try, experiment, and fail early.
Thank you so much, Professor Simon See.
Pleasure is all mine.
Interesting discussions and useful points has been highlighted over this podcast. Thank you so much for joining us in this podcast. And as we said normally in the end of each podcast, this podcast is not predicting the futures, but how to prepare for it. Thank you so much.
Thank you very much.
Thank you, Professor.
My pleasure.
Thank you.